Well, hello everyone. How's it going? With the strange way Zoom works, I can't always see myself here. So it took me a minute to scroll through the video to make sure that you could actually see my face.
Hey, how are you?
I am well, thank you. How are you guys?
Very well, Josh.
Good.
Cool.
We're good.
Excellent. Well, I am here in California, which means it's right about 6 p.m. my time. But the first question I always like to ask in a class like this is, who's furthest from me? Who's furthest from California right now?
I am.
Um,
I'm not
In
sure.
Russia, it's 7 a.m. here.
It's 3 a.m. here.
oh,
It's only 9 o'clock here.
Wow.
Okay. Okay. For anybody, is it like yesterday still, or tomorrow still, or yet?
Tomorrow.
Tomorrow.
Oh no, it's still today. I guess they're moving it.
All right. Well, I won't ask you for the future then, or I won't tell you the future. But okay. Cool. So first, I am really happy to be doing this class again and to be joining all you guys. So this is going to be fun. It's going to be challenging, but I hope it's going to be a little bit of fun too.
What the fuck is this? You said it was a black thing. Fuck, he did it. That's my charger. How the fuck did you bring me a goddamn cord cable? What's wrong with you? Fucking
First,
can't tell that's a damn, what you call it?
You said it was in your car?
if everyone will go ahead and mute your microphones for me. It's in the bottom left of that Zoom window. Thank you very much. So here's generally how this works. So this is a live class, meaning we're all here together, or most of us are here together. So that the benefit of that is that you get to ask questions, right? Any time you want for the time that we're together. And I really encourage everybody to do that. However, when you're not asking a question, I do ask that you keep your mic muted, because that can cause not only feedback and all sorts of things like we had a moment ago. Not nearly the most epic of them, but that was fun. But also in the recorded version, if you choose to go back and watch this later, or if we have people who can't make every time, and some people who are only doing the delayed version anyway, and they watch the video, if somebody else's mic is on, it'll often just cut mine out in the recording. And I've been told that I don't know why this would be the case, but I've told people want to hear me talk. So so when you're not asking a question, just keep it muted, and then when you have a question, just unmute and ask at your discretion. I really want to encourage everybody to ask as many questions as they want. So that's housekeeping item number one. Housekeeping item number two is that not everybody is going to really be wanting to use their voice like during class. Some people just prefer to type a question out, and that's totally fine too. But I do ask that if you type a question, type it into Slack and not into the Zoom chat. And there's two reasons for that. One, Zoom is not so great at letting me share my screen and see the chat at the same time. It's a little bit obnoxious. And so if you type it in the Zoom chat, I may not even see it in the course of class, and that's kind of sucky. So ask it in Slack, because I always have that window open, and I'll always be sure to see that. The second reason to use Slack instead of the Zoom chat is that if you use Slack, and there may be a case where I'm like, okay, we're going to get to that next week, or we don't have time, we're out of time. Let's put a pin in that. I'm going to answer that later. If it's in Slack, I'm not going to forget. If it's in Slack, it's right there, and I'm not going to forget. If it's in Zoom, the Zoom session chat is gone as soon as we hang up. So that would be too bad. So if you want to type a question or anything, use Slack. If you want to use your voice, just unmute and ask the question straight away. I encourage both of those things. So as you guys, that's the end of the housekeeping stuff. And as you guys no doubt have noticed by now, I have somewhat of an outsized personality and an obsessive love of caffeine. So those two things are going to combine together to create a maybe more high energy presentation than some of you may choose if you had the choice. But that's just me. I'll tell jokes along the way and hopefully have some fun. So this class is really Q&A focused. So if you were to look at the syllabus that's on the class page, there's always like this little description, and then there's this question scope. And that's because the way that each class is outlined is I have some things that I want to talk about, and I have a backup, so if nobody has any questions at all, I can fill the hour. But I really prefer to fill it talking about what you guys want to know. So I've outlined like 9 things that I think, big picture wise, you should probably know in order to count as knowing JavaScript. And within that, I outlined this question scope. So anything in there is fair game as far as I'm concerned. So if you have any questions, like between today and Monday, or between Monday and Thursday's classes, or whatever, then you can ask them in that second channel we have, the JS Q&A channel. And that is just like my queue of questions to cover in the next class. So if there's something you really want to know on the next topic, ask it in JS Q&A, and it'll be in the queue, and I'll know. And if you tell me in advance that you have this question or you want to know about a particular topic, then I can actually prepare some better examples than just asking it and then answering it on the fly. Of course, you're welcome to ask it on the fly too, and I'll try to answer it on the fly, but I can prepare a code example, for example, if you tell me in advance. Yes, the JS Q&A channel is here in Slack. It should be JS-Q-N-A. Let me know if you don't see that. You should see that. If you don't, I'll ask Kara to make sure that you guys all have that, because you should have 2 channels on Slack. Okay, I'll take care of that. For those of you who don't have that yet, I'm going to ask Kara after class, but you can ask them on the regular JS class channel too, that's fine. The reason we have the 2 channels is so that if there's a large volume of questions and a large volume of conversation, which sometimes there is, then they don't get lost. That's the only reason that there's 2. So, yeah, hunt around for it. If it's not there, we'll find it. Okay, so this class is also focused on like big picture stuff. So we're going to be talking about, does somebody have a question? No? Okay. For those of you who just joined us, go ahead and mute your mics when you're not asking a question. That way it doesn't cut out mine, but in the bottom left-hand corner of the screen, you have a mute button. So the big picture stuff, that's the stuff that's harder to find in tutorials. So a tutorial will tell you how to create an Angular directive, or it'll tell you how to maybe add and remove DOM nodes, but it won't tell you how to think about the processes that go into doing that. They're just not very good at that. Tutorials just kind of don't do that. So that's where we're going to focus in this class. We're going to focus on those big picture concepts through those practical examples. So it's not going to be about, here's all the functions you need to know in JavaScript, because frankly, you can look that up. We're going to teach you what to look up. We're going to teach you how to find what you need, how to think about creating a real web app in the real world, and some of the things you want to think about along the way. So we're going to be focusing on those big picture stuff. Because we're doing that, this class is going to be a little challenging. And I feel like I would fail in my job if it wasn't a little bit challenging. So if you guys aren't finding the class challenging, let me know, and I'm gonna dial it up to 11. If you guys are finding it too challenging, let me know that too. Every class is different. We have a different mixture of skill sets and experience levels and all kinds of things in each class. And I'll again, it's Q&A driven, so I'm gonna try to tailor it to that. So what we're going to do over the next 9 hours together is create a to-do app. So we're going to start out today just working kind of casually with some test-driven development. We're going to learn some ES6 concepts for those of you who aren't familiar with them. But we're just going to talk about the concept of testing. And I start out every JavaScript class with testing because it's something that is always left to the end. It's something that, and if you go and find tutorials and you go and find books, they'll teach you 9 chapters of stuff, and then they'll be like, oh, by the way, here's how you test. And to me, that teaches people something that's really wrong. It teaches people that testing is an afterthought. Testing is something you do once you have the code figured out. And I think that's the wrong way to think about it. I'm not alone in that. So we're going to start very first class with some test-driven development. Next week, we're going to actually create some, our to-do app, really, a primitive version of our to-do in the browser. We're going to create some DOM nodes, some lists. You can check things off and remove items and that kind of stuff. We're going to create that real to-do app in the browser. But we're going to learn that there's a lot of weaknesses in the way that we approach that because we're going to do it the wrong way. And in our next class, we're going to talk about prototypes, we're going to talk about inheritance and constructors and classes and all that kind of stuff. And that's going to help us figure out how we can think about data and how we can manage the data that's running in our to-do app. And then we're going to connect it together and we're going to do it the right way. We're going to go back to what we did in second class, and in class 4, we're going to rewrite that part in the browser the right way, the way that you may not find immediately in a tutorial online. Then we're going to talk about asynchronous stuff. We're going to talk about promises. We're going to talk about observables. I'm a huge fan of observables. I love observables. So we're going to talk about that. It's going to be a good time, or at least I'm going to find it a good time, and half of you will find it dull. But we're going to do it anyway, and I'll try to make it fun. And then we're going to move to the server side. We're going to talk about Node. We're going to talk about NPM. We're going to create a whole REST API. We're going to create a whole API to manage our to-dos, manage our to-do list. Okay, and then we're going to go and learn about Webpack. And we're going to use Webpack to build our front-end app, and we're going to connect our front-end to our back-end. So at that point, we've done full-stack JavaScript, right? So we're going to create a front-end and a back-end, and we're going to connect them all together. And that brings us all the way to the last 2 classes. In the last 2 classes, we're going to fill in some gaps with a few things. We're going to talk about the developer concept. We're going to talk about where you go from here, what you guys might want to learn next. But more importantly, we're going to say, all right, we did that in plain JavaScript, and you're probably not going to do that in the real world, right? In the real world, you're going to use a framework. So we're going to take that front end that we wrote, and we're going to rewrite it first in React, and then we're going to rewrite it in Angular, okay? And if along the way there is, say, consensus that you may want to take a look at Vue, V-U-E, instead of Angular, because I know that's got a lot of buzz around it, I would be happy to swap Angular with Vue. But I want to keep React in there because that's my thing, and I'm trying to convert y'all to being fans of React. I'll let my bias be known. Okay, so that's our whole class. That's what we're going to do over the next nine sessions. So I remember to use the Slack chat instead of the Zoom chat, so I can. So I'll see it later on because I see that there are some +1s in there. But as soon as I like start screen sharing, I'm going to lose that chat, and it's going to be a pain. And so, do that there. But I can show you a code example. Like I can port it, and I can say, here's what it would look like in Vue, but we won't have the time to cover it if we're also covering Angular. So think about like, I can show you, here's Angular, here's Vue, but let's spend the next hour talking about Vue, or I can do the reverse. It's up to you guys. Oh, good question. So in real time, while we're here together, ask questions in the regular JS class channel because I can't monitor both. But between classes, if you're saying, hey, next class, we're talking about the DOM, that's true, by the way, next class, we're talking about the DOM, and you say, oh, I want to know about how to do blank in the DOM, put that in the JS Q&A channel because that's my to-do list, right? That's my list of stuff that you guys want to cover next time. And the JS Q&A channel will be just that, whereas the JS class channel is going to get a little polluted. It's going to have conversation that's going back and forth, people talking about homework or activities and all that kind of stuff. So just because I don't want to lose your question, I don't want to like forget that you asked. So we created that whole channel just to keep it in one place. Okay, cool. So that's it. 15 minutes or just under 15 minutes of all the stuff before we ever got started in there. Oh, I actually did forget one thing. Damn it. Okay, one more thing, and then we'll actually get into some code. There are activities that you guys should do. Of course, you're not required to do them, but you should do in between each class. And at the end of class, we're going to just really quickly go over it, and I'm going to drop the link inside Slack and pin it so you guys have access to it, and then you guys can play with it. And it's going to be based on the code that we just wrote, right? So the code that we're writing in class today, you can take these activities and build on them. And what those activities are activities to do what we're going to talk about next time. So next class, we're talking about the DOM. We're not going to talk about it at all today. But the activities are all about doing something in the DOM. So it's my challenge to you to see how much of this can you figure out on your own, using your own experience and your own Googling and the small amounts of information that I gave you in the doc, how much of it can you do yourself? Because in different classes it's different, but some people just with their experience and so forth, they can just devour that and read the documentation and basically do all of the activities. That's not most people. Most people land somewhere in between. They're able to do this piece and not that piece or whatever. It's my job to say, okay, well, all of you learned this already on your own. So we're not going to waste class time talking about that. We're going to build on that and then go to more advanced stuff, right? So we can use that time that we would have spent talking about something you all already knew with something better. And each of those activities, or most of those activities, will have code, right? Because this is a JavaScript class. And you can submit, we'll go over this last bit at the end, but you can actually submit a pull request against the code repository if you want me to take a look at your code and see how you did. Okay. So there's that as well. Okay.
And I have a question. If we struck in between, so we need to post that in the Q&A session, right? On the activity, we got a doubt and we struck. So how do we contact you? Is it through Q&A or?
You can, if you just have a question, just like a general question on the activities or anything else, you can hit me right in the JS class channel. If it's something like, how do I blank, it's something we're talking about next time, put it in the Q&A channel. Now, the distinction between the two is not that big of a deal. It's just, if you really want to make sure that I get to it next class, put it in the Q&A channel so it doesn't get lost. That having been said, I'm on Slack all the time, so there may be a slight delay if I'm busy. I do have a job, but that I'll try to reply in Slack whenever I can. That's how you can get a hold of me. I'm also on Twitter and LinkedIn and Facebook and everywhere else too. So you're welcome to look me up there too, and we can be friends. Okay, so. That having been said, let's dive in. Let's go ahead and get started. Okay, so we're going to talk about test-driven development, TDD. Question from Slack: will they be recorded? Yes, they will. And the recording will be available. It's within 24 hours, but Kara's been really good about getting it done pretty fast. So like oftentimes it's in the morning after Pacific time. So, like 12, 15 hours later, but within 24 hours, the recording will be posted right into the Slack channel. And there'll also be a link on the class page for the recorded session. Great question. I'm sorry, I forgot about that. We don't really have much in the way of slides for this class, but we're going to go with the code. The code will be on GitHub and there'll be a link in the activities, and then I'll post the activities in Slack. And I think Kara will put a link to that after class 2. So you'll have a link to that there as well, but it's always going to be in Slack so that you have that. Dave asked about pair programming. I do actually recommend that. That's a really good idea. And some classes form little groups and kind of go through these activities together. It's a great thing to do. If you don't want to, of course, don't do that if it's not your thing. But if it is your thing, if that's your bag, then pair up and hop on groups. You can hop on Zoom sessions or Google Hangouts or Join Me or any of those many like video conferencing, screen sharing sites and Code Away. It can be helpful to do that in pairs because the activities will be challenging, as you'll discover at the end of class. Okay. So test-driven development, what is it? Well, let me go ahead and share my screen, and we're going to talk about it here. This always takes me a second because this one it doesn't filter the Zoom when I select my screen share. It doesn't filter the windows for what's on this workspace. It's showing it on all my workspaces, and I don't want to accidentally share the wrong window, which I've done before, and I guarantee I'm going to do it at some point in this class. At some point in this class, I'm going to share the wrong screen, and it's going to be 5 minutes before anybody says, dude, I have no idea what you're talking about. I can't see that. And then I'm going to have to go back and talk about it again because the little green outline of the window is just simply not enough for me. But anyway, so here I'm in my editor here, which we'll be talking about definitely a bit more. But this is Vim. I'm a big fan of Vim, but it's not for everyone. You can use whatever editor you want. I mean, literally, you can use Windows Notepad if that's your thing. If you really want to, you can cat and echo and sed and awk and do it all from the terminal and be totally elite if you want to. But there are tons of great editors out there. We had a conversation on Slack, some of us, a little while ago about some editor choices. I stand by those. You know, if you're Atom and Visual Studio Code are both free and open source, and are mostly open source, and they're great editors to use. And then there are about 30 others that are also great. Mac people tend to like TextMate and Sublime. So you can feel free to grab one of those as well. Vim has a bit of a learning curve. Because it's a modal editor, which we won't really talk about what that means in this class, because I could spend 9 hours talking about Vim, but it has a bit of a learning curve. I found it deeply rewarding to spend the time it takes to learn that, and I'm super productive, you know, inside of Vim. But that having been said, it's not for everybody. If you want to give it a try, if you want to be elite like me, kidding, then you can actually grab my Vim configuration, which is on my GitHub page. It's Josh D. Miller on GitHub, and I can drop a link in Slack if you guys are curious, and you can just download my configuration and give that a go if you want to try Vim. But again, it does have a learning curve. Okay, I will drop the link into Slack after class. Cool. And then feel free to ask me any questions on it, because I don't have a lot of documentation. Every single class I teach, I say, oh, by the way, if you want to, go try it. And every single class, a couple of people go and try it. And every single time, they're like, how do I install it? And I'm like, well, at some point, I'm going to get down to a README. But I think if you add it up, all the time I've spent on Slack saying how to get my configuration running, that I could have easily written 5 or 10 of these READMEs by now. Okay, so here we are inside my Vim. Because I don't want to share my whole screen, I have Quad HD, I have a 4K monitor. So if I were to share my whole screen, nobody could read anything that I have written on the screen. So I'm only going to show one window at a time. And because we're going to be running the tests constantly with writing code, I don't want to switch back and forth from my terminal to my Vim window. So I'm going to stay inside Vim. A lot of the editors that you use will allow you to run commands in them. If not, like if this is in the real world, if I wasn't sharing my screen, I'd just be doing it in the terminal. And so in Vim here, if this exclam just means I'm running a command that I would otherwise run in the terminal. So I'm going to run a command like, oops. There we are. npm run _silent test. Now, this _silent is optional. I'm just doing that to truncate the output a little bit, so it's a little friendlier inside class here. I'm just, this npm run test command is exactly what you're going to run inside the terminal. We're going to run this probably 10 or 15 times in the course of this class today. And this is just going to allow me to run my tests. So if I click enter here, it's going to run them all. No, this output is a little funky because, again, I'm running it in Vim. If you were doing it in the terminal, it'd be nice and pretty, or prettier at least. But you can see I ran it ran one file. There was 0 tests and 0 passed. But nevertheless, the result was okay because nothing failed, right? So at the start of it, we have no tests whatsoever. Okay. Does Vim have auto indentation and auto completion? It sure does. So like if I go to the end of this line, I hit enter, I'm already indented here. If I were to say do something, and then if I were to unnecessarily indent, and then this one got outdented or something like that, I can indent it. On my key binding, I have it set to it's equals, so I would just do like equals 3J, and they're all fixed, stuff like that. So yes. Anything you can get in any other IDE, you can get in Vim. It's just a question of whether or not you're going to work for it. So yeah. Okay. So the basic setup we have here, and for when you guys go and play with this a little bit after class, when you did get the code from GitHub and you want to mess around with it a little bit, we have essentially 3 files that are important. One is just this package.json file. Now, we're going to learn a lot more about package.json files when we go to learn about NPM, go to learn about Node. Because NPM is a package file for Node. It's a Node package manager. Node has files called package.json. So we're going to learn about all of those in a couple of weeks. But before then, excuse me, I'm sorry. I choked on my own words. This script here, if you were curious, when we do npm run test, npm run test is the command we use to run our test. This is the command it's running. It's running the tape command. So if you're really curious, that's where it's happening. Okay. Other than that, don't worry about this file at all. We're going to come back to it at a later date. Okay. we have two other files. So inside of the source folder, we have index and spec. Now, I'm not going to keep this open simply for purposes of screen real estate, but I'm going to open a tree. Why didn't you open? The heck? Refresh, man. Why is this doing this? For some reason, the output is wrong there. I don't know. That was weird. There we go. This is what you should have seen. All right. I don't know why I was getting a little funky there, but okay. So if you're in our JS live class code folder, right, we'll have a folder called source. And in fact, if you download this right now, you won't have a static or a dist folder. You'll just have node modules and source. Inside the source folder, in fact, you won't have most of this either, but you'll have index and spec.js. Those are the two files, right? Source, index, spec.js. Because this takes up so much screen real estate, I'm not going to have it open. Just know index.js, spec.js, they're both inside the source folder. Okay. So here is our index.js file. All of our main code is inside of our index.js file. And you can see we're creating 3 functions that all get exported. And we'll learn more about modules later on. You're free to ask questions about them whenever you want, but just know we have 3 functions that are getting exported. One is double. This is simply going to double a number, really, really boring function. Then we have one that's going to double a number of times. So we can double 2 6 times, for example, right? And then we have, and that's also a very boring function. And then we lastly have a double each function where we can give it an array and it's going to double every item within that array. Okay, so we have 3 functions that we're going to write, but we're not going to write them right now. We're going to write the tests for them first because this is test-driven development, meaning our tests drive the development of it. What that does is it forces us to think about the implementation or to think about the function signatures, to think about the contract, to think about what we're going to give a function and what we're going to get out before we ever write it. And you're going to end up with much, much, much higher quality code. And there's a few links that'll be inside the activities of things you can read, the really short articles, that'll explain this concept a little bit more. From Slack, am I supposed to clone something or just watch the screen? For now, just watch the screen. I don't necessarily recommend like trying. You can certainly type and follow along if that's your bag, but since we're with us, since we're in such a short time, I'm going to try to move kind of quickly, and you might end up missing something along the way. But all of this code again will be right on GitHub, so after class you can download and play with it all you want. After today, you'll see the pattern of the code, so you can feel free to. You could browse day 9's code tonight if you wanted to. So there's nothing stopping you from doing that. Although I don't recommend you do that before you try the activities. Don't cheat now. But you could do that, and that's entirely up to you. But for the moment, we're just focused on this. Okay. So we're writing a test. These tests are just functions. So we're telling Tape is our test framework. We're telling Tape, okay, Tape, I want to test something just for my own purposes. I'm going to call it the double function. Why? Because it's the function that doubles stuff, right? So it's our double function. And the second argument that we give is a function. And this is what Tape is going to run when it wants to run our function. And that function takes in an argument called test. And this is just a little variable that we can use to do stuff with. There's a little boilerplate here you don't need to worry about, but we have to tell Tape when we're done with our tests just in case they were asynchronous and so forth. So, but ignore that. That's just boilerplate for now. Okay, and anything we want to test, we're going to drop in here. Now, it said that we were running no tests, right? When we did npm run test, whoops, normally it's up one, but there wasn't because I ran the inner tree. Okay, when we run our npm run test here, it says it's running 0 tests. Why does it say it's running 0 tests if we have a test right here, right? If this is our test. It's because there's a confusing set of terminology. When you're running tests, you have your testing library or your testing framework. This for us is Tape. Then you have what are called assertions. These are the actual tests. These are things that we are testing to be true, that we're asserting to be true. And when Tape is outputting, or any other library is outputting, you ran X number of tests, it's talking about these assertions. Now, if you're using a library like Mocha or Jasmine, usually this test function is one-to-one with assertions. You run one assertion per. It doesn't force you to do that, but that's what they say the best practice is. In the case of tape, because the library is structured a little differently, you don't need to worry about why for this class, but I did include an article in the activities if you want to know. But because of the way it's structured, we're not going to do that. We're actually having multiple assertions per. So it's saying that we have 0 assertions. So we didn't test anything, right? We have a function where we're going to write tests, but we haven't tested anything yet. So what we want to do for any tests, right, is answer a question, right? We want to say, given a certain set of circumstances, when something occurs, then I expect something to happen. GWT, given, when, then. Any test follows given, when, then. They all do, right? So we're going to say, given this double function, right? That's what we're testing. Given this function, we have no other state, nothing else we care about, just given this function. When we tell it to double 2, we expect it to get 4, right? Given the double function, when we give it 2, then it should give us 4, right? It's a pretty stupid function, but that's what we're going to say. So I'm going to write tests in a very explicit way. So I'm going to declare variables called actual and expected, right? So I'm going to say the expected value, if I were to pass in 2 to a double function, I'm expecting it to get 4 back. Okay. The actual value is the one that we'd get by calling this function that we haven't even written yet, right? Which is double. So if we call double 2, we're expecting 4. This is the value that actually comes back, but we're expecting it to be 4. Now we tell tape, here's what we want to test. So we're going to do test.equal. So tape, and again, you can click the link in the activities to read the full API here, but it has a set of these assertions that we can run. Things like equal, which is really the only one we're going to care about today, which tests whether 2 values are equal. So we're going to test that our actual value equals our expected value. Okay. And then the last argument we can give is, again, something friendly to print out in the case that it fails, right? So I'm going to put something like should double the number, because that's what it should actually do. Meaning if this test failed, it's because it did not double the number. Now, we haven't even written this yet, but we're going to run our test and we're going to see that it's going to fail. And here we go, right here, not double function, right? That was the name of our test function. Not okay, 1, meaning the first assertion that we ran, should double the number is the one that failed. 1 second. Figured it was better to mute my mic to cough than force you to listen. Okay, so our should double the number. Now we said which operator, right? Which assertion did we run? We testing something was equal. We expected a value of 4. We actually got undefined, and then it tells us where in the file that actually occurred, right? And we can see in our summary down here we had 1 test fail, right? There was 1 test and it failed.
Okay,
Right?
so before you created empty functions, is it the common practice to do that when doing test-driven development?
So I would say yes, and so that's a good catch. Yes, I stubbed out the function because if I didn't, let me show you. So let me switch over to index.js, and I'm going to comment out this function, right? So now it's no longer defined. When I go to run my test, it's actually not going to fail the test. I mean, it will, but it's going to fail in a really weird way. So it's not going to show me any of this stuff. It's just going to say that double isn't a function because it's not, right? I didn't define one yet. And so what we're really trying to do here is test that we implemented the functionality right? The function that we haven't written yet. So what we're going to do, and so what we just did before I comment that out, is we wrote the test that says, here's what I'm expecting to happen. We watch the test fail. Then we're going to go write the function, run the test again, and now the second time the test is going to pass. That very specific structure of red to green, right? Of going from red to green, test fail to test pass. The reason we watch the test fail first is because many, many, many times you'll have an error in your test. You won't be testing what you think you're testing. So what we want to make sure is that the value that comes out of this function, that literally the value that gets returned from double, that is the value 4. And now this one would be very hard to have that kind of error. But let's say for some reason I did. I had some weird thing in my code here, and I wasn't testing what I thought I was testing, or let's say that actually my expected value wasn't 4, I accidentally put something else and it ended up being undefined, right? Then it's testing the actual undefined, expect is undefined, and that test passes. But that's not really right because I wasn't really expecting this. And again, you're not writing a unit test on your unit test, you're not testing that your tests work, right? So the way that we do that, the way we get around this infinite regression of testing that our test is right, is by watching it fail first. We watch the test fail first, and then we go back and write the code and then run the test again. And now the test passes because we watched it fail the first time. So the reason I stubbed out the function was because when I commented it out, I didn't get a real failure. I got double wasn't even a function. What I really want to test is that if I have a function called double, when I run it, that it's going to return double the number I give it. And so in order to make sure that my test is actually doing what I think it's doing, which I know it is here because I'm saying I'm expecting a value of 4 and I got a value of undefined. Because I can see this here, I know when I run the test, when I implement the code and then I run the test, if the test passes, it's because the code was right and not because there was an error in my test. So that's why I stubbed the function test. That's why I say it's a good idea to do that too. Anytime you're writing, it's just stub out the function first. That way you don't get a JavaScript error and you're not really testing it. And this is not a beginner thing. Like this like stubbing out the function and going, from red to green. That's not a beginner thing. Everybody thinks it's a beginner thing. It's not. Let me tell you something that is absolutely true. All right, and you'll probably see this at some point in class. If I write code and then I go write a test, which I don't follow TDD all the time, right? That's just not something that I do. I'm experienced enough as a developer that I'm making the call, right? Sometimes it'll be like, I know how I'm going to implement it, so I'm just going to implement it, I'm going to play around a little bit, and then I'm going to go back and run the test. Because I know that I'm going to end up with decent enough quality in my code that I don't need the barrier in that case. That's not always the case. It's very often not the case, but sometimes I do that. But if I'm going and I have to write a test for an existing block of code, and that test passes the first time, I do not trust it, ever. Because I'm pretty sure that I screwed something up and my test was wrong and I wasn't testing what I thought it was. As I can't tell you the number of times that I had a test for something, or I've been doing code review for somebody else's code, and I see a test, I'm like, that's not testing what you think it's testing. Or I screwed up and this test wasn't testing what I thought it was testing. And so if I get a test to pass the first time, what I'll actually do is go to the code that it's testing and comment something out, and then watch my test fail. Because there have been plenty of times where I commented out and the test still passed. That was because there's an error in my test, right? So I never trust a test that passes the first time. So that's why I stub them out. Okay. All right, so now we have this test. We're expecting it to return a value of 4. So I'm sure you can all guess exactly how we implement this incredibly dull function here, right? We return x times 2. Not very exciting. But let's watch now, and instead of having an actual value of undefined, we should have an actual value of 4, which we do. And now we see that no test failed and one test passed. Right? So that was really, really dull and really, really boring. But we wrote it anyway, right? So now let's think about double x times, right? So we want to write a test for that. So because I'm testing something completely different, I'm going to write it in a separate test block because I'm testing something completely different, right? So there's a little bit of art and a tiny bit of science to how you go about structuring, like what you put, in which tests and so forth. That's really, it's probably 50% personal preference. I think the broad stroke is anytime you're going to be bleeding state between the two things, or like I have to set something up differently to test something else, put it in a separate one. Or if you're testing something completely different, like we are here, we're testing double x times just the double function, then do it in a separate one. But you could definitely use the same one, and it wouldn't be wrong. It just might not be ideal, right? So one question I always get is how do you go about structuring these? Through experience, you'll learn what you like and what you don't. Okay, we're going to set up roughly the same thing. So we're going to say that our expected value, we're going to give it 2 again. And let's say we want to double 2 5 times, right? Then we're expecting to get the value of 2 doubled 5 times. 4, 8, 16, 32, 64, right? So that's the value we're going to get out. And the actual value would come from calling double x times, passing in 2 and 5, right? Passing in the number we want to double and then the number of times we want to double it. Then the other part is just the same. Laziness forces me to copy and paste, right? Should double the number of times provided. You could probably come up with a better description than that, but that's what we got for now. And of course, this test is going to fail because we haven't implemented it yet. Right? So we can see we're expecting 64 to equal undefined, and of course it doesn't, right? 64 and undefined are not the same. So now we can go implement this, right? All right, so to go implement this, we can think about how do we want to actually write this, right? What is a good way to do this? We know we need to iterate a certain number of times. We only need to do this once for every time that num was passed in, 5 in our case, right? So the quickest thing most people probably just reach for is a for loop, right? So let's just like set up some structure. We know that we're gonna have some value that's our result, right? And we're gonna end, and it's gonna start with whatever was passed in, right? Like 2. 2 is what we're starting with, we're gonna double it 5 times. And we know at the end, we're gonna return that result, right? So then most people are gonna say, all right, well, to get to that result, we could use something like a for loop. That's what we're gonna do here. So we're gonna do for let I equal 0, I less than num, I plus plus. And for those of you who aren't really familiar with a for loop, and I don't really blame you for not being, because frankly, it's going to be extraordinarily rare you use a for loop in JavaScript. If you're using a for loop in JavaScript, I honestly say, like, take a step back and ask yourself if you're doing it, if there's an easier way to do it. Because usually for loops are bad. We're gonna come back to that in just a second. But here's what this means. Okay, so for loop has 3 arguments. The first one is just a declaration block. We're just creating a variable, in this case called I. I is common because I stands for iterator, right? We're iterating over value. The second one is the comparator. And the third one is what's run at the end, what we're using to increment here. So here's how this happens. Before the first run, before the block inside these brackets, right? Before that runs, it runs this and creates a variable called I and sets a value to 0. Then it runs, then it tests, should I run the block, right? Since say, is I less than num? In our case, we passed in 5, right? So is 0 less than 5? Of course it is. So it's gonna say, all right, I'm gonna run the block. So then it runs the block. Then after it runs the block, it's gonna run this. And now I is not 0, it is 1. Okay, then it's gonna say, all right, now I'm gonna compare again. I'm gonna go back and care. I'll go back and compare again. 1 is still less than 5, so I run it again, and then I increment it again. When we hit 5, right, it's going to say, when we run this the 4th time, it's going to I plus plus, I is 5, and it's going to go back, is 5 less than 5? 5 is not less than 5. 5 is equal to 5. So it's not going to run that 5th time or that 6th time, and so we're going to be done, and it's going to move on here. That's how the 3 of those things work here. We're going to come back to let and var in just a second. Because there's an important distinction there that I want you guys to research. I'm going to give you a little experiment to figure out the difference between let and var, right? All right, so inside here, so we're going to do this once for each time. And all we really want to do is say result equals 2 times x, right? Or 2 times the result, right? So we're going to take whatever the result was, and we're going to double it. I think it's probably a stupid way of writing it. Result times 2, that's an easier way of writing, right? We're going to double this. That's what this line is doing. We're going to double the value that we have the number of times that we're passed in, right? So it's going to start with 2, right? Result is 2, and then it's going to double it, and 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 now 5 is not less than 5, so it's done, and it's going to move on, and we're going to return the value of 64. Right? So let's run that. Yes, I will explain why I think loops are bad. And it's not loops are bad, it's why I think for loops are bad, but we'll come back to that in just a second. All right, so now our test passes here, okay? All right, so here's an experiment that I want you guys to use, and Sam is right on point there with the difference here. This has to do with variable scoping. Let is one of the best, easiest things that you get from ES 2015, right? From what we used to call ES6, from the latest version of JavaScript, right? It's one of the best things to come out of it, and it's something that has such a technical reason that most people don't really know. And so here's what I want you to do. So what I want you to do is after class, download this code and do a console log, right? Console log will just print something out in the terminal, right? So do console.log. And then print out something like, and I'm going to use template strings here because we're doing all ES 2015 all the time in this class. So do something like I equals, and then print out the value of I, right? Then do it inside the for loop, and then do it after the for loop is done, right? Do this with var. and run this each time, right? When it runs here, I is not defined and it's going to error out, right? But then you're going to get these here and you're going to get all of these here. Then change it to let and see what happens. Okay, these console logs will be different. They're not going to be the same between let and var. And that's my experiment. That is my challenge to you, is experiment with that and see why let and var are different. But Sam is right if you want a hint. It does have to do with variable scope, which is a really important concept. The long and short of it, okay, is that I literally do not use var ever. I always use let for that very same reason. And I challenge you to find out more about that. Okay. So, and by the way, that let var distinction is one of the reasons I don't like for loops. We're gonna, after we do double each, where we're gonna do another loop, it'll be a lot clearer why I think that you should always rethink using a for loop. It's not because the for loop is necessarily bad. It's just that there's usually an easier, more readable, shorter code way. Okay. Ivory asked, are there browser compatibility issues with using ES6 with IE11 or IE Edge? No, but this gets into a weird territory because the standard is the standard, but not all browsers implement the standard. And yeah, IE is notoriously bad for implementing the standard. That having been said, okay, it's called ES 2015, right? We're in 2017. Meaning these things have been in the spec for years, and lots of browsers are just sucky. Actually, only a few browsers are sucky, and don't include that functionality anymore. That having been said, it does not matter at all for the code writing here, because we're actually not relying on Internet Explorer or Chrome or Firefox or any browser from having this functionality, because we're actually compiling it with Webpack. So I'm sorry, with Babel, and in the later classes we'll be compiling it with Webpack, and next week, in fact, we'll be compiling it with Webpack. So we're going to compile down to plain JavaScript. So it's going to get rid of lets, it's going to get rid of consts that I've used in the test. It's going to get rid of fat arrows, which we're going to use a lot of in this class, and a few other things that we're going to make use of. It's going to get rid of those. And so that the browser, so you can, anything we write in this class, you can use in any web app you want to, as long as you are transpiling. I don't often use that term, but yes, Matthew, it's technically transpiling. As long as you are compiling that down to regular JavaScript, which basically any web app out there does. You just do it. If you're doing React, you're doing it already. If you're using Angular, you're doing it already. If you're using any other framework, you're probably doing already anyway, even though it's not required. So just do it. It's going to make your life easier, and it's mo better. But good question, because I would imagine IE11 does not support let. I could be wrong about that. I think IE Edge does, but I could be wrong about that. But we're transpiling it anyway, so it doesn't matter. Okay. So now that we have that test passing, we can do our double each functionality. Right? So let's think about that one. So if we go back to our test here, and uncomment that, I'm going to scroll down. All right, so we're going to do the same thing. So we're going to say our actual value, right? I guess I could have done these in the reverse order, probably would have made a little bit more sense, but our actual value, we're going to expect that if we call double each, and we give it an array of values, like let's just say 1, 2, 3, 4, 5, right? We're going to expect, that was me using autocomplete, by the way. You asked before if I could do it. Yes, I can. All right, so anyway, our expected value then we should be getting 2, 4, 6, 8, and 10, right? Each of those numbers doubled. Not yet in class have I thoroughly botched doubling a number in my head like 4 or 6, but it's only a matter of time. So feel free to call me out for being a moron if I accidentally have done bad math here. All right, so that's what we're expecting to come out of it, right? And now we can do test.equal, and we're testing that our actual is equal to our expected value, and it should double each number in the array. Ooh. Okay, Now we haven't implemented the code, so of course this test is going to fail on us. It's going to say that those two arrays are not equal, right? One's not even returning an array at all. Okay. So now, let's go and implement this, right? So we know we're going to have the same type of thing. Okay, so we're going to start with some type of array, and we know at the end we're going to return that same type of array, right? And now we know we need to iterate over each item in the array and then double it, add it to result, so that we can return it at the end. So here's how somebody might think to do that using a for loop. So we're going to do let I equal 0, and we're going to say I is less than the length of the array that got passed in, and then of course just add it by 1 in between each run of it. So you could do it this way. Now we could do result.push, which is how you add an item to the end of an array. We just do .push. So we do result.push, and we're going to add in to this value whatever the array value at that particular index, right, at I, so starting with 0, and then 1, 2, 3, 4 for the length of the array, times 2. Obviously that n does not belong there. Okay. Right, so we could do something exactly like that and then return the array at the end. So let's run this. Now what's interesting here is that this test is going to fail. So if you see here, we have operator equals expected 2, 4, 6, 8, 10, actual 2, 4, 6, 8, 10. Does anybody know why this failed?
Different objects with a similar but object equality versus object identity.
That's exactly right. They are different objects. And this is a really important thing to note when you're dealing with JavaScript, right? Is that we're comparing two containers, right? Objects are containers, and an array is a kind of object, right? So objects are containers. Now, these two containers contain the same values, but they are two different containers. They're still different containers. If you want to think about it really technically, a variable, right, is pointing to a place in memory. And you have in JavaScript two different kinds of variables. You have what are called primitives. Those are things like numbers and strings and so forth. Primitives are only ever in memory once, right? That's essentially it's how you can think about it. They only memorize. So there's only 1, 2 in memory. And so if we create two variables and set them both to 2, they're essentially pointing to the same place in memory. I'm oversimplifying here, but that's it. When we create objects, though, those are not primitives. Those are objects, and they have their own place in memory, right? So we could have two variables that are pointing to the same object in memory. But if we create two objects and set them both to the same contents, which is exactly what we did here, two arrays with 2, 4, 6, 8, and 10 in them, it's still pointing to two different places in memory, even though the contents are the same. But that's okay. Because in our test here, we're actually not testing that it returned that array. That's not what we want to test. If we go back to our unit test here, what we want to test is that the contents of these two arrays are the same. That's really what we carried out. We cared about that it returned an array and that array had the same contents. Almost any test framework you use or any assertion library you use is going to have a function to help with that, and it's called deep equality. Deep equality is if you take that object and you dive down into it and look at every key value pair inside of there, they should have the same values. Okay, so we can test that inside here using a function called deep equal. That's what tape calls its deep equality checker. Other libraries will have different names for them, but ours is called deep equal. So the deep equal is going to look that inside the actual and expected containers that they both contain the same values. And you can see here that they do. Okay. So now we have that test passing. So let's go back to this. All right. So let's go back to this. Now we did this whole thing using a for loop, right? And now this is one of the reasons that I say that for loops are probably not the best way to do this. Because, I mean, yes, this works and it's fine and it's probably not going to be too, it's probably going to be performant, like there's not going to be any performance problem with doing it this way. That's not really the issue. The issue here is that it's not super readable. It's not really clear what's going on here. And this is also a little bit, I'll just say it, it's ugly. It's fugly, right? It's super hideous code to look at. It offends me to look at this code. It's just so ugly. It's not really friendly at all. And plus, we have way better ways of dealing with this. Not to mention that this code is not reusable. The code that's inside here is not reusable, whereas we really do want this code to be reusable, right? So let's see if we can rewrite this. Well, arrays have functions on them that allow us to iterate over each item. And there are several of them. There's one called map, and there's one called for each. For each is essentially a for loop like we're doing here. So we're going to do the array that we passed in dot for each, right? And then for each value in this array, right, it's going to execute the function that we give it. This function is going to take in the item at that point in the array and run this function. So we're going to do the same thing, result.push, and we're going to do item times 2. Right, so when we pass in, I'm going to comment this out. So when we run this function here, right, when we run array.forEach, it's going to call this function 5 times, once for 1, 2, 4, 1, 2, 3, 4, 5. It's going to run it 5 times, each time doing a push of each of these items into it. Okay. So now if we run this test again, our test still passes. Now note what we did here. I didn't change the test at all. I didn't have to, because the function signature, the fact that double each takes in an array and returns an array where each number was doubled, didn't change. This is called a refactor. We're going to come back to that concept in just a second, right? But I refactored this code. So I can run the exact same test to know that the changes I just made are still good. It's not going to cause a regression, meaning a bug to come up that wasn't formerly in there, right? That we thought we were testing for, because we are in fact testing for it. Okay. But so we have this for each. For each just calls a function once for every item in the array. But we can actually do something slightly different as well. So array has another function called .map. So .map will do essentially the same thing. It's going to run a function for each item in the array, but it's going to return a new array for that is filled with whatever this function returns. And again, this function is called once for each of the 5 numbers that we passed in. So we can just do return item times 2. And now our result is filled with that new array of double numbers. Okay, so our test still passed. But we can actually now simplify this even more, because we really don't need this or this, because all we did was create a variable and then immediately overwrite it. So we can just do return array.map. Right, so now our code is getting shorter as well. Okay, and our test still passed. But through the beauty of ES6, through ES 2015, through the fat arrow feature, we can actually make this even shorter. Okay, yeah, I'm just gonna do that. Okay, so I'm gonna do return array.map, and I'm gonna do a fat arrow function. So item fat arrow. So this fat arrow is a way of doing a function that has there's a technical reason for it. It's called a function bind. It's called function binding is really what we're doing here. It's how the fat arrow works. We're not going to get into that right now. Just know that it's not exactly equivalent, but it's used in the way I'm doing it here all the time. I actually have an exercise that I can give you guys if you want to play with it. That you can use to learn more about that. But essentially, it's a function. It takes an item as an argument, and I'm going to do an implicit return, which means this is only a one-line function, right? I could do exactly the same thing I had before and said return item times 2, and this is still going to work. In fact, I will show you that it works. Okay, so we have the same thing here because I did this implicit arrow, but this didn't really save us much, right? It saved us function, and then because I only have one argument here, the parentheses here are optional, right? So I really only saved a few characters, you know, by doing the fat arrow. But in this case here, the fat arrow is going to help me in another way, because in a fat arrow, I don't need it to be multi-line. In this case, I only have one thing that I care about here. I only care about doubling this item and immediately returning. So I can use the implicit return syntax to do this. Implicit returns means it's going to take whatever on this one line, not literally on one line, but before the semicolon, it's going to take what's there, whatever this returns, which is if it's 1, it's 2, if it's 2, it's 4, if it's 4, it's 8, right? Whatever that is, and it's going to use that as the return value of the function. So now this is exactly equivalent to what we have below. Okay, and our test still passed. But if we can use that here, we could also use that here. And it still passes. If you're not familiar with ES6, this basically looks like magic. If you're familiar with ES6, it's kind of duh. But if you're not familiar with ES6, this totally looks like magic. So let's walk through this real quick. I know we're basically out of time here, but we're right at the end anyway. So I'm just creating a new variable. That's just how I chose to do this, right? I'm calling it double each. I'm setting it equal to a function that takes in an array as an argument. Okay, so it's an array. It takes in an array as an argument that comes into the function, and the function spits out that the array dot map, right, which returns a new array, just like we did down below, calling the function inside these parentheses for each item in the array. So we passed in 1, 2, 3, 4, 5. So for each one of those 1, 2, 3, 4, 5, it's getting called, and the new array that gets returned will be filled with 1, 2, 3, 4, 5 times 2, 2, 4, 6, 8, 10. So we can simplify it all down to that one line from all of those other lines that we had right there. Okay.
And for the above for loop, there's no other option, right? Either it will be a for loop or while loop for the above function, double x times.
So are you asking if we could do that up here?
Yeah, I mean, on the double x times, instead of for loop, the other way is like using while loop, right? Is there any other shortcuts? Yeah.
Not directly, no. A lot of languages like CoffeeScript will give you a way to like quickly create an array of a range of variables. So like you could do, 0 to num. Like in CoffeeScript, for example, you could do like const array equals. I think this is right. 0 dot dot num or something like that, and this would suddenly be an array of 0 to that number. JavaScript has no such construct.
Okay.
So there's some magic, some one-line magic you can use to create an array from a number that's like that, but it's not built in the language. It's really people hacking it. Yeah. So unfortunately not. There's not a lot of ways to simplify this one.
And how do we get that project structure, like package.json, index, source, modules?
In our node class, which is I think 4 classes from now or something like that,
okay,
we'll go through exactly how to do that.
Okay, right now I don't need to worry about that, right?
No, right now you're just going to pull down my code and it already exists and there's instructions in there to get started with it. But no, you won't have to set any of that up.
Okay.
Good question. Good question. Why does the function turn into a variable? You mean on this line, Matt? I assume. So the function doesn't turn into a variable. But that's a really good question. It's an interesting way of asking it. So in JavaScript, sometimes you'll hear people say that JavaScript is a functional language. That's not technically true, but JavaScript borrows a lot from functional languages. In that, I won't go into detail there, but one of the things that you'll find is that JavaScript treats functions as first-class citizens. It also treats objects that way, which we'll talk about a week from today. But functions are first-class citizens, which means when I do something like function myfunc, right, or whatever, when I do that, that is actually equal to me doing something like var myfunc equals function. Those two are now equal. What this does, this is a shortcut for creating a variable called myfunc that is a function. Right? So these two are the same. And because I told you I don't use var anymore, I used const. And why did I use const? I used const because const means that that whatever I assign to this variable, I can never assign this variable to something else. Meaning, if I were to do right here something like my func equals 17 or 12 or whatever, something like that. If I were to do that, right, this is going to error out. It's never gonna run. In fact, I'll show you. I'll prove it. It's not going to run. Oh, come on! Don't make me scroll. Kind of ruins it if I have to scroll there. Let me see. I may have done that because it was already declared. Oh, come on, scroll. I don't remember the shortcut to scroll in there. But anyway, it's going to error out. It's going to tell me that I tried to assign a new value to a constant. It's because that's what I said. I said once I point my func to a place in memory, which is what I did, right? But when I creating a variable is just creating a name that we can use that refers to a point in memory, right? It just points to some place in memory. It's saying I can never point it to another place in memory. It does not say that place in memory can't change. So remember, this is a primitive, right? So if I do a constant like, if I do a constant like this, const my func equals 12, right? 12 is a primitive. It's only one place in memory. It's never going to change, right? 12 is always 12, right? 12 can never be something else. But let's say I did, that's no longer a function. Let me change it to my num to be less confusing. Okay, so now let's say I create another constant like my object. And I create an object with a key like message hello. Wow, that was really far from hello. Okay. Okay, so let's say I did something like this. Now, my object is referring to an object in memory, but even though it's a constant, because my object is referring to a place in memory that's a container, I can add in a new property. Aha! Right? Or I could even alter an old one because I did not change to what my object referred. My object always refers to this place in memory. Meaning when you declare a constant, you can just never again do my object equals. You can't follow it by an equal sign. But I can change whatever's in that container all I want because I'm just not changing what this means. This still means the same object, even if I change its contents. Anyway, that's why I use constant. So I know that you didn't really I know that really didn't have anything to do with your question, but that's why I used const here. So I told you I don't use var. So I use let for anything that I expect to change because yes, I agree. You use let to be able to reassign it. Let is equivalent to var in that case. So I use const for anything where I don't expect it to change. Any reason for export before something? Yes, because we are importing it right here. So if I didn't export it, I couldn't import it. We'll talk about more when we get to Node. It's not super important now. Just know that I did what's called a named export, meaning I said I exported a variable called double each, right? It's a named export called double each. I exported it here, which means I can import a double x times and double each by their name in this file. That's why we exported it.
Okay.
Okay. So now we have all that done in there. That's kind of magic, you know. This will all be, it won't be exactly the same, but it'll because the code is from last time. But you'll see on GitHub, you'll see a similar type of flow here in the code there. You can see how simple that we can get those kinds of things down to one line. But there's one more improvement I want to make here, even though we're over time, and that is that we're repeating ourselves. Result times 2. Item times 2, we're doing the same thing in all these places. So remember we said when we when we change the internal implementation, right? We don't change what double does or what double x time does or what double each does. We change how it gets there. We don't need to change our tests because we're still testing the same thing. The internal details didn't matter. It's called a refactor, right? So we can refactor this to do return or result equals double result, right? Because we already have a function to do that. Now, in this case, you could argue whether or not it's necessary because it's such a stupid thing, right? But whenever you have functionality that does some things, does something already, you don't want to do you don't want to redo it. There's a principle in development called DRY, D-R-Y. Don't repeat yourself. And so we don't want to repeat ourselves here, because if we ever had to, you wouldn't in this case, but if you ever had to change how something happened, you'd have to change it every single place you did it. And that gets old really fast, right? So I refactored it. My test should still pass. And of course we do. So all is well in the world there. So there are in a refactor, you do not have to change the tests. There are some cases where you do. When you're not refactoring. If you're adding new functionality, you have to add a test that covers the new functionality, right? Because you added new stuff. You need to make sure it too is tested. If you change the contract, right? The contract in a function like double, right, is that it takes one argument in and spits one argument out. That is double, right? That's the contract. The contract is given one number. I'm going to return double that number. That's the contract. If I ever change that contract, I will have to change the unit test, right? If I ever add new functionality into here, I have to, for example, I have to add new tests to cover that new functionality. And there's one more thing, a bug fix. So let's say this is not a case you could encounter with something as simple as like doubling a number. But if you double this number here, right? If you double x times, right? If we change how, if we, for some reason, let's say for numbers over 1 million, it didn't work, or something stupid like that, right? Let's say it didn't work. So we went in and fixed this, right? We fixed it and now it works. You still have to add a new test, even though the contract stayed the same and all you did was fix an implementation bug. You still have to do it because of this thing called a regression. Later on, it could break in the same way and you're gonna get the same bug coming back. So if it was failing for numbers over 1 million, you'd add a new test for numbers over 1 million, and then it would fail, and then you'd write the code to fix the bug. Now the bug is fixed, and now your test passes, and now you're good. And that bug will never crop up again, because if it did, your test would fail, and you would know that you screwed up royally, and now it's time to go back and make sure that you don't cause that regression. There's nothing worse than your business partners seeing the same mistake happen more than once. Makes us all look really bad. Okay, I'd also add a new test double x times with number triple equals once. So it's obvious that it's equivalent to double. Yeah, you could do that if you wanted to. Yeah, there would be nothing wrong with such a test as well. In fact, you could just do it this way and say we could combine double and double x times into one function and say if num is not provided, or if num is 1, then just return double the number, and otherwise return double. Return double that sequential number of times. Right? There are other ways we could do it as well. In fact, look, we could do this. So I'm going to comment out double. I'm going to replace this with double. This is going to be a new double function, and I'm going to specify that the default value is 1. Right? And now in this file, I'm going to replace all instances of double x times with double.
Will fail due to recursion.
I'm sorry?
This will fail due to recursion.
Oh, yes, thank you. Since the refactor, it would fail. Thank you. Oops. Okay, so let's run our test again. And now, I borked it again. Where did I bork it? It's probably in here. I'm gonna run that in the terminal so I can see the output. So just 1 second. Oh, yeah, okay. It was just my find and replace, copy pasta, imported it twice. Okay. There we go. Now all of our tests passed. So we refactored it, right? We're still running the exact same test on the double function. And we renamed the double x times function to double. So we're still running the exact same test on double, only now double is getting 2 arguments. But what we said was, we're going to change it so that now the double function can take an optional number of times, defaulting to 1, that we can double the function. So, now, Alexander, we've done the both things all in one, if you really wanted to do something like that. Okay. All right, that is that, folks. So I'm going to drop a link in Slack now, and I'm going to go over it here. So there is the link in Slack. I'm going to switch screens so you don't have to open it if you don't want to right now. You can just look at my screen and see the same thing. Right, here are the activities for day one. Let me shrink this window a little bit so it'll get a little bit bigger on the screen share. Okay, so day one activities. Again, you're going to get one of these for every time, and this is going to go through maybe some things to think about with what we already talked about today, but the activities are all about what we're going to talk about next time. So what we're going to talk about on Monday. So here's a brief little thing. Go ahead and set up your environment, download and set up Node. There's a link there. Play with the REPL, and then download the code. And here's a link to the code that you can use to get it running, right? So there's all that. I told you there are going to be articles on test-driven development, so here they are. And here are a link to 2 exercises that you can try. So I said that I had some of those ES6 exercises. Here's 2 of them. The way that these work, they're pretty straightforward. They're all inside JS bins. You can see I create a variable called sum in this example. So I set sum equal to a function, and for any argument that gets passed in, we go ahead and sum them all together. So you can see down here's a unit test, right? Sum 1, 2, and 3. We expect that 3 plus 2 plus 1 is 6, right? So we're just going to add every number that you pass to it, a variable number of arguments here, right? But I also have a version here that you can uncomment. And this is now the ES6 version, and it's your job to fill out this function in a way that will make this work, right? And so this one is called rest and spread, and so I do put a link. Right, it's just JavaScript rest and spread to fill out, so you can try to get that working here, and feel free to ask any questions you want in the Slack channel. And there's one more for template strings. So here are 2 ES6 things that we're going to make use of in this class. Feel free to play with these. If you'd like more than these 2, go through these 2, make them work. And if you want more of these for different ES6 features, let me know, and I'd be happy to provide them. Okay. Then here's the stuff for next time. JavaScript in the browser, right? So create this basic DOM structure here, and there are some notes, including the branch of code that you're going to use, and then where you can go to view this in the browser. You should just see a welcome message when you do. And here are some steps to follow. First, create the view, set up the state of the application using JavaScript. Don't use jQuery, and then render out some UI. And in order to do this, in order to implement this whole to-do thing, as I've done it here, as listed here, you only need these 3 new functions in the browser, and I've linked directly to the documentation for them. Okay, so you only need these 3 functions. This whole implementation can be done in just a few lines of code. It does not take that much. Okay. Then, if you get through all of that, I gave you a bonus. So add some new functionality, things like deleting to-dos, adding new to-dos using a form, making to-dos editable after they're created, maybe clicking on them to mark them as complete or something like that, right? So there's all kinds of things that you can do right here. And then a lot of these will have a reflection. These are things that I want you to think about. Things that maybe challenge how you go about, how you conceptualize something, or how you should be thinking about something. And I said, we're going to be doing this the wrong way. So one of these is to think about, what are some of those weaknesses? Okay. So that's that. So give these activities a try. I really encourage you to do so. Give these activities a try. And if you really want to, you can write the code as you think it should be, and then submit a pull request against the branch that's mentioned in there. Submit a pull request against that branch, and I will review your code for you. I will provide some helpful feedback, or just give you a pat on the back if that's what you need, and anything to help you guys go along, ask questions on Slack and so forth. Otherwise, this is what we're talking about come Monday. So if there's anything in that space you want to talk about in the browser and DOM, in that questions scope that you see on the syllabus on the class page, ask me in JS class or JS Q&A, and I'll make sure that gets in the list. Okay, so thank you for joining me today, and I really look forward to doing this 8 more times with you guys. I can tell you guys are a good and fun group, and that's not always the case, so yay. And I hope everybody has a fantastic weekend, and I will see you on Monday, all right?
Yep.
All right. Yes.
Thank you.
See you guys.